Hello and welcome to the final episode of our incredible three-part series featuring Virtual Fly SWITCHO, FlightDeck, and our incredible SLAVX cockpit. Really excited to have you here. If you didn't check out series episode number 1, that features Oscar and myself just after AirVenture talking all about the brand new Virtual Fly SWITCHO product, which you can see here in our SLAVX panel, as well as the EFOS and SWITCHO-RADIOS actually running right here. So we're going to walk through a demo of those. Episode 2 is actually building this incredible flight deck cockpit. Everything from the seat to the structure to how the monitor mounts to the flight deck, as well as the computer base. Everything is included here in the flight deck. We actually build it from the ground up. And episode 3, which is why you're here. And this is integrating everything with our incredible SLAVX cockpit. We're going to talk all about the different features of this overall setup, what we actually did to modify a few things, such as even cutting the poles on these monitor arms to bring them a little bit shorter so they didn't stick up above the monitor. All the way down to powder coating the base of our SLAVX panel black so it matches the rest of the SLAVX cockpit here that we have. So really neat. Just going to go kind of component by component. Everything that we have here, we have ForeFlight running here on our iPad mini. That's actually connected to Microsoft Flight Simulator. We're going to actually shoot an approach into Chicago Executive runway 16. We're going to pick up Krenna to Haigu, so we'll walk through all of that approach, and you can actually do that same exact approach in your simulator as well when we get to that point of the video. And then we've even got everything down to the details, such as wanting to use a Bose headset with your panel and plug it in with the same general aviation connectors that you use when you fly the real plane. So we've really got an entire host of great things here in this series. We're going to finalize it. And yeah, let's go ahead. Let's get started. So once again, thanks for tuning in. This is really an awesome product setup. These SWITCHOs have been in development for a very long time, and we're really excited to be able to have a scalable, integrated SLAVX cockpit panel here that can be customized to any customer liking. So for example, if you don't want to use the SWITCHO switch panels or the trim panels, or maybe you have a different yoke instead of the Virtual Fly YOKO, you can actually have us build you a complete custom cockpit that will still mount to the overall Virtual Fly flight deck. And so it's really scalable, it's very modular, and it's infinitely customizable to your needs. So what I would say here is, as we go through all the different components, I want to talk just a little bit about really the overall layout here, what we have in the panel for starters, and then I want to talk about some of the different scenarios that we're going to do for the approach. And then we're going to wrap it up talking about EFOS and SWITCHO-RADIOS that we have over here. So in the panel, we have the SWITCHO over here. These are from Virtual Fly. These are the lights on the bottom. And then we have the starter switches and the battery alternator and those switches. And then over here in the middle, you can actually see the Aviatek G1000. We chose the Aviatek G1000 because it is the absolute highest quality G1000 that there is. And there's no better way to talk about the quality of the G1000 than to go to the real plane and bring the Aviatek G1000 with us and actually compare it. So let's actually go to a real plane that's running the same G1000 NXI that you see right here in the simulator. All right, hey guys, so we just decided to come out to the field. Why not? Let's see the real plane right here. If you can believe it, this is a beautiful 2020 model year Cessna 172. This is the G1000 NXI here. And what we'll go ahead and do, we'll actually flip this on right here. And we can actually compare and see just how close and realistic this Aviatek G1000 is to the real thing. Now, we're not going to be able to power up the Aviatek G1000. This is really from a buttons perspective, from a knobs perspective, how tight it actually looks. And so we're going to get in there with an additional camera and really just get that tight look in comparison to the real thing. Okay, so just looking at the comparison here, the Aviatek G1000 to the real, you can see just even with the mounting bolts right here, just how seamless it is in mounting. You can look at the buttons, the knobs. Everything just looks just like the real aircraft. the tightness of the knobs, the rubber feeling of the encoders. You can look down here, right here at the bottom. Just looks absolutely fantastic. Just right down here. It looks absolutely fantastic. So that is the Aviatek G1000. Okay, so thanks for taking a little tour to the airport. As you can see, the Aviatek G1000, the quality is just unmatched. It really is the best in the business in this space. Down a little bit lower, we've got the Virtual Fly YOKO, an absolute staple of a yoke, a great yoke in the industry, and just very, very solid. We've got the rudder pedals underneath the YOKO. And over here on the right side, we've got a pause button here, so you can actually just pause the simulator very quickly. It just plugs in through a USB, just push the button. And then down at the bottom, once again, is that headset adapter, so you can actually plug in your general aviation headset right into your panel and use that as an audio comm device. It's got microphone and speaker if you'd like to use an add-on ATC such as Pilot Edge. Now we've got the Vernio throttle here, replicates that Cessna 172, and then below that we have the SWITCHO trims panel. And all these layouts of these components have been very thoughtfully designed with where they are in the actual aircraft. The lights are to the left side. The starter is to the left side. The trim wheel and flap lever to the right side. So when you're flying and training in that left seat of a Cessna 172, things are very familiar with where you're moving your hands. You're not trying to kind of flip-flop. And really that's important because you can build bad habits in flight simulation. It's completely possible. And then when you go to your flight training, you have to undo those bad habits and you need to build good habits. So it's always really important that if you feel like you're not training in the right way that you should be, bring in a CFI to your home or even go to the school's simulator and make sure that you're building the right habits correctly. It's going to really help you in your training a lot. So as we come to the back of the flight deck, you'll see a couple of things. You got a computer here, and then you've got a speaker and subwoofer system. So these all mount here onto the flight deck plate, and that speaker subwoofer system is really important so we can hear the actual aircraft. But the subwoofer is actually really nice because it gives you those low bass tones of when the engine's actually running. So I actually really like having just a small little compact subwoofer there too. The computer, this is a very basic computer. It's running Microsoft Flight Sim 2020 on high-end settings. We'll see what we're getting kind of from a frames per second. I believe we're getting about 30, 35 frames per second, which is very acceptable in the simulator. But it just has an RTX 3060, 32 gigs of RAM, a 512 gig NVMe solid state, and an i7-12700. It's nothing crazy. It really isn't. If you can believe it, this gaming desktop was $999. Found it on SlickDeals. If you're not on SlickDeals, get on slickdeals.net. Costco's always got a ton of really great things in there. So we picked that up at Costco and it seems to be running great. I actually swapped out some of the fans inside and I go on a little tangent, but there's two 80mm fans and there's a 92mm fan in the back. The 80mm is the front and the CPU fan. I popped those out. I put in three new fans, two 80mm and a 92 from a company called Be Quiet. These fans move a ton of air and they're super quiet. The bearings are amazing. I can't even hear this thing's running. I also redid the thermal paste on the CPU cooler and its temperatures are great. The performance is great. The RTX 3060, not even a 3060 Ti, but the 3060 is just doing great. So really excited to share those awesome high-def graphics with you as well. So that's really the overall layout of the flight deck. It's comfortable, it's a great seat, it's a supportive seat, it's mobile, it's lightweight, it's got wheels, you can move it around, literally. We can just wheel it over here, wheel it over there. It's great, it's very mobile. So that's flight deck, but I really want to show off flight deck. I want to show all this stuff working. I want to show the approach on ForeFlight and actually getting and coming out and busting out of minimums busting out of the clouds right at minimums, right at our DA, our decision altitude, because we are going to fly an ILS, a precision approach, an ILS into Chicago Executive Runway 16. Our scenario for this, and this is what I really like to use simulators for, is this scenario-based training. That's where it's so important. If you're just trying to fly VFR in a simulator, okay, that's neat, but it really shines in instrument training and building the right instrument training tools. And so our scenario here that we're going to build is we're going to be coming from Janesville, Wisconsin. We're going to be going to Chicago Executive. We will have departed out of Janesville. We will have gotten changed over to Rockford departure from Janesville Tower. We're on with Rockford departure. We got transferred over to Chicago approach. And now we're on with Chicago approach. We're approaching the fixed Krenna. That's Kilo Romeo Echo November Alpha. So we're approaching Krenna, and then our next fix after that is going to be HIGU, Hotel, India, Golf, Uniform, Hotel. So we're Krenna, HIGU, we're going to intercept the ILS-16, and we're going to fly that down to minimums. Now, we're also going to do this as a partial panel. So we are going to lose our PFD functionality right in front of us, and we're going to have to use revisionary mode to be able to have all of our, I say, avionics right here on the MFD. So you're going to see me looking over to the right a lot to make sure I'm on localizer and to make sure I'm on glide slope. So that's a great scenario-based training environment that we can do with this setup. Now, if you're just tuning in and you're new to Stay Level Avionix, you're new to our channel, maybe you're new to aviation, maybe you've just taken a discovery flight and you're learning how to fly, what Stay Level Avionix does is we produce these cockpits. We produce them for the tabletop, and we now produce them for the virtual flight deck as well. And so we build these once a month, and we actually build them all here in Chicago. We do all of the CAD design, the manufacturing. We've got an entire team ranging from Ryan in manufacturing and engineering to Francisco in powder coating to myself, who then finishes up the panels and gets them shipped. So we've got a whole team at Stay Level Avionix that is here to basically make these cockpits and panels infinitely customizable to the components that you have. Whether that's the Aviatek G1000, Virtual Fly, VF1000, these new Virtual Fly EFOS components, Real Sim Gear components, Desktop Aviator, I mean the list goes on. Our goal was to bring the most amount of compatibility to consumer grade and consumer accessible flight simulation hardware, and then be able to put it all together in a wonderful, beautiful, high quality panel that really is a lifetime product that you can pass down to future generations. So that's what Stay Level Avionix does. And so strong engineering team, strong manufacturing, and we're proud to continue to keep doing that here in Chicago. So we're going to go ahead, we're going to get into the demo. As I mentioned, we've got a kind of mock approach that we're going to do this with, and we're going to go ahead, we're going to get in, we're going to set it up. You're going to be able to see the actual approach. We're going to kind of try to maybe do a little bit of picture-in-picture, and we're going to go ahead and we're going to shoot this approach down to revisionary mode in the G1000. So let's go ahead. So we're sitting here in our virtual flight deck. We've got everything together, and I'm going to be really quiet. Let's see if you can actually hear the computer fans. It's pretty minimal. So I'm really, really happy with this computer. It seems to be working really well. So this is ForeFlight here on my iPad mini. I've got it here, and I've got what our routing is here. It's Janesville, direct Krenna, direct HIGU, and then for the ILS-16 into executive. So we are currently about halfway between Krenna and HIGU. So we're going to pick up on the way to HIGU, and during that, I call it on the way to the HIGU fix point, we're going to be doing all of our approach preparation procedures. So we've got a checklist, we're going to walk through that, and we're going to go ahead and we're going to pick it up there. So we are here, we're in the plane, and we are at 3,000 feet, and you can see here, we've got all of our avionics right here. So if I go ahead and push enter, we go ahead, we've got our moving map right here. We can go to our traffic map. I like to fly in real life with our traffic map quite a bit. Just because you can really see a lot of the detail. So Krenna was out over here. We're flying direct to HIGU. And once again, those fixed points are Krenna, Kilo Romeo Echo November Alpha, then to HIGU, Hotel India, Golf Uniform Hotel, Krenna HIGU. So Krenna HIGU, and then we are going to hit PAMI. We're going to get into the approach here in just a minute for the ILS-16. Now, I like to think about these things really straightforward in a three-part segment for building that approach. Kind of looking, how far out are we? Right now, we're 9.4 out of HIGU, and so we can definitely start that approach checklist right now, because we're going to get up to HIGU pretty darn quickly, and we can actually slow up our power just a little bit for that. So, ATIS, build, brief, checklist. Say it with me. ATIS, build, brief, checklist. ATIS, build, brief, checklist. That is a really, really good order to do those things in. And so ATIS, let's go ahead, let's say we got the ATIS, we went over to Comp 2, we got our ATIS at executive. The information is alpha. They're landing runway 16, and the winds are right down 160. Couldn't get any better for an approach in the 172. So that is the ATIS portion of it. Now that we have the ATIS portion, we understand where they're landing, we can start to build that in the avionics. And so what we can do here is we can bring up our flight plan that we have, and we can see our origin was Janesville, then Creno, now we're direct Haigu, and we can push procedure, and we can push select approach. We're gonna select the ILS 16 vectors, and then we can go into our minimum section. So where do we get that? And that is where the build and brief really comes together. So we can go ahead. Now, if you're not using the plates functionality in ForeFlight, I highly recommend using plates. And what plates does is it's down here at the bottom. You got airport, maps, plates, documents, imagery. You got a lot of different things, logbook, etc. What plates is it's an opportunity. You create a binder, okay? And you can see binders. You can add a flight binder. You're going to create a flight binder, and I only have one flight binder. And what you then do is you can put in whatever airport you want. It pulls up all your recent airports, but you can put whatever you want. And then you have three categories here: airport, departure, and approach procedures. So you got your airport diagram right there. Then I can see any kind of departure procedures, and I can see any type of approaches that we have here. So ILS 16, RNAV 16, all right there. So I can flip between things really well without having to click on maps, bring up executive, which by the way, extended center lines is awesome also. And we're 5 out from Haigu, so we gotta keep going here. But my point with this is, if you're using plates, you don't have to go back and forth switching between maps, clicking the map, clicking info, looking at your frequencies, then hitting procedure. You don't have to do any of that. All that is there right there within plates. So highly recommend plates. Now, where are we gonna get those minimums that we're just gonna put in here? Minimums are 9 to 7. Now, that's not the only part of building and briefing. We're gonna actually read the entire approach plate. So, really important here to read that. We're just gonna set up the avionics real quick though first for those minimums, 927, so we're gonna go up to 930 on minimums. We push enter, and then we go ahead and we're gonna hit load. Because we haven't been cleared yet to deviate from our direct Haigu from ATC. So we'll talk a little bit about what that call looks like as that starts to happen in just a few minutes. So we're still going towards Haigu. As you can see on our avionics, we're about 3 out from Haigu. We've got the picture here in ForeFlight, and something I really love to do in ForeFlight as well is I like to go ahead, I like to push that arrow right there in the top corner, and I like to put that approach right on the map. So now it sees my plane, where I'm going, and the approach. Now, we're getting real close to Haigu, so we're gonna have to brief this. So, how I brief it in the plane, top to bottom. You don't need to read an entire novel. You need to really just pull out the key highlights. I like to visualize my missed approach with my hands as well. And so, this is and I'm just gonna pause it real quick. I don't wanna blow through Haigu here. This is the Chicago Executive ILS runway 16. You wanna make sure you have the right airport. You don't wanna be briefing for the wrong airport. I've actually seen that happen in the plane before. So I've heard of students doing that. So you don't want to be briefing the wrong airport. You may be going from one airport to another, and they might have the same VOR Alpha or VOR Bravo circling plate, actually. So just little things like that. You always want to read out that airport. So this is the Chicago Executive ILS runway 16. ATIS 124.2. We went ahead and got that. That would be in here in our COM2. I like to use ATIS COM2. But then Chicago approach. Let's say we are talking to Chicago approach. How that sequence works from Janesville. We're talking to Janesville Tower. We got handed off to Rockford departure. We then got handed off to Chicago approach. And then we are on with them right now. And then we can anticipate that we're going to get handed off to Executive Tower. So what we want to do is make sure, so we're on with Chicago approach, let's say. We want to make sure we get that CTAF 119.9er in there for Tower. And what I like to do is I like to talk to approach on COM2. And then I like to put in my tower on COM1 and then my ground on COM1 as well. So then once I land, I'm clear of the runway. All I have to do is one push, and then I'm over to ground. So just little things like that. Be thinking ahead of the airplane as much as you possibly can. So tower and ground will be in. We'll do that. Now this is an ILS, so we're going to fly that with our nav1. And the really nice thing about the G1000 is it's already put that frequency 109.9 0.75 in there, and it's already identified it as well as PWK. So that's really great. It's already put that in there and identified it. Now, the final approach course is going to be 161. You can see this white line here that's been drawn out. That's our final approach course, 161. So it's really drawing that whole final approach course out. When we are told to no longer be flying the Haigu, or for example, cross Haigu at 3000, until established on a localizer, we're going to get close to Haigu and we're going to push the CDI button. We're going to change our nav source from GPS over to that nav1 to be receiving that localizer frequency and displaying it right here in our HSI. So that is what's going to happen there. That's our final approach course. That's why that's important. Now, if we look at PAMI, that's our final approach fix. PAMI at 2,300. So really important to know that that's our fix, final approach fix. We cannot get under that altitude at that final approach fix. Really important to hold that altitude. And that's at or above as well. Now this is an ILS. We want to be right about 2,300, but that's what that is there. Now ILS, DA. This is a DA, a decision altitude. This is a precision approach. So once we hit, because we're on glide slope, once we hit that DA, we go missed. Okay, once you hit that altitude, you're gone. You're going missed. Now, question for everybody: can you start a turn before your missed approach point? Think about that. So let's say you get down to minimums. Maybe you slightly dip under minimums because now you put the power in and you're going around to go. Excuse me, not going around, going missed. So you can deviate just slightly under that DA altitude because you're going missed. But can you turn before that? What's the answer? The answer is no, because you can't turn before you missed approach point because there could be obstacles, there could be trees, things like that. So it's really important to keep the direction until the missed approach point, keep that missed approach, that climb coming, and then you can make your turn. That's really important. So we're going down to a DA, a decision altitude, airport elevation 647, touchdown zone elevation 643, slightly under that. Our missed approach is going to be a climb to 1,400, then a climbing left turn to 2,700, direct OBK VOR and hold. Continue the climb and hold to 2,700. So if you look at that climbing left turn, how would we enter that hold? And a really great way of how to remember how to enter that hold is that's going to be a parallel entry. Now the G1000 and other Garmin Avionics really favor a teardrop entry, but one kind of hack to remember this is you enter, you can see here, there is the protected part of the hold, the right side of the hold on this plate. And that's the protected area. And so parallel, protected. If you're entering from that protected side and it's not direct, it's parallel. Teardrop would be from the other side, the unprotected side, and then you come in. And the reason that the Garmin Avionics feature a teardrop so many times, if it's kind of questionable, is because a teardrop is within the protected area of a hold. So that's where that is. Anyhow, so back to the plate, that's our missed approach. Now, once again, I'm talking a little bit more than I would be in the plane because I'm trying to kind of explain a little bit for those of you who aren't familiar with some of these instrument procedures. I want you to just have a little bit of a general understanding of kind of what that is. And so that's why we're talking a little bit more. Then you can see the visual graphical depiction here under it, and we can just kind of look at the plate. We can anticipate what we would do. In this instance, because we're going direct Haigu and they've cleared us and we've heard the words cleared straight in from ATC, that means we wouldn't need to do any procedure turn or anything like that. We also wouldn't do a direct to Haigu and then a really sharp left turn for that 45 out and back around to intercept the final approach course. And so that kind of that out 026 heading 206, we wouldn't be doing that because that would just be a very aggressive move basically if you were flying that. So anyhow, you can kind of graphically see where it is. You can see your distances down here, how far away from the runway threshold they are, and things like that. So DA versus MDA, really, really quick. So DA, decision altitude, versus MDA. MDA is a minimum descent altitude. Think of it as like a floor. You can't go under it. Just like a DA, you can't really go under it. But the MDA is a place where you get to, and then you can kind of hang out and you keep flying until you hit what's called your VDP. This is the easiest way that I think about it. You hit your VDP. So if a VDP is not depicted on a plate, how do you know how to calculate your VDP? And what you do is you take your height, AGL, divide it by 300. And you're gonna get a number, probably like 1.5, 1.7, 2.0, somewhere in there. doing approaches, be really, really important and careful to look. Are you doing a DA, which is typically that ILS precision approach, or is it an MDA? Now, there's RNAV approaches as well. Whether they're precision or not precision is kind of up there. It's more a guidance approach, right? Because it's not a ground-based system like an ILS. So we're not going to get into approaches totally, but there's a lot of great resources online to learn more about these things. So that's DA versus MDA, ILS, precision approach, and we are going to do the ILS 16, which once again is a DA, a decision altitude. So once we hit that DA, once we hit that altitude, because we're on glide slope, we're gone and going missed if we do not have the runway environment in sight. And that's really to ensure, one, a stabilized approach, a safe landing, the required flight visibility, just all those different kinds of things. So we're approaching Haigu, and let's say ATC clears us, call sign SLAVX 123. You are cleared for the ILS 16 into executive upon crossing Haigu. Cross Haigu at or above 3,000 until established on the final approach course for the ILS 16 and executive. Once again, I'm not ATC, so this call isn't perfect. So they tell me, okay, at or above 3,000 at Haigu until established. And they may say, hey, once established, you can change over to tower frequency on 119 or 0.9er. They'd probably hang on with approach until closer to the final approach fix and then take us over to tower. But that's what we kind of expect. So we're going to go ahead. We're going to fly to Haigu at 3,000, and then we're going to change our nav mode and get established on the localizer. So hopefully that was pretty concise. Once again, this isn't flight training here. This is more just kind of some general understanding, so you guys have an idea. Always get to with a BGI, an AGI, or an IGI, which is a basic ground instructor, advanced ground instructor, or an instrument ground instructor, or just go with a certified flight instructor, or a certified flight instructor with with capabilities to teach instrument, a double I, often is what it's called. So once again, these are just kind of some understandings. Like I talked about earlier in the video, you can build bad habits in the flight simulator. So don't build bad habits. Make sure what you're practicing is correct, and make sure what you're practicing is accurate. You don't want to be building bad habits. That's not a good thing. So, invite your CFI over, invite your double I over, and just say, hey, I want to shoot a couple approaches with you. Just so when I can go practice these things when we're not flying, I want to make sure I'm doing them correctly. I want to make sure I'm briefing everything correctly, not missing anything, working the avionics well. Now, as I mentioned earlier in the video too, we're gonna have a panel failure. That's what I think is gonna happen. So we're gonna need to go into revisionary mode and some things like that. So we're gonna be shooting the approach here on our MFD. So we're gonna talk a little bit about what happens with that, how it's all gonna work, and everything else. So I'm gonna go ahead and we're gonna unpause and go to Haigu. Okay, so we're gonna begin slowing down to about probably 195 knots or so. Once again, talk about that ATIS build brief checklist. We got the ATIS. We built the approach in our avionics here. We then briefed the plate with ForeFlight, and then we're gonna go through our checklist real quick. Approach descent. ATIS, we've got altimeter set. It's 29 or 9 or 2. We set it on our standbys as well. Approach brief is complete. Altitude select, we're gonna remain 3,000. Our minimums are in right here, 930. Mixture adjust during descent, we'll go full rich. Fuel selectors on both. This is the only thing that's over here to the left side instead of the right side. But yes, it's on both. Parking brake, check released. It is in. Landing light is on. Yep. And CDI soft key, select nav source. So here we are, 0.8 from Haigu. We're gonna start that turn Haigu inbound, and then we're gonna disconnect the autopilot, and we're gonna change our nav source to intercept. So that is our approach descent checklist complete. And so here we go. We are going to autopilot off, flight director off, CDI, and we can begin our turn now. So we want to intercept, we want to fly the tip of the needle there, and so we could say localizer alive at that point. It is moving, it's active, it is alive. So localizer is alive, and so then we want to, we're at 3, good, great news. So we're looking here at our plate, PAMI at 2,300, so we can actually go down to 2,700 kind of from that VOR, so 200 to go until our next altitude. We want to be really vocal here on our approach as we're talking about all the different altitudes.
and make sure that everything is looking really, really good. So we're actually on the approach. Oops, so we're gonna go on the approach mode here, PAMI, direct, enter. So we're on the approach. Actually, technically that was our flight plan, that's GPS. Doesn't even matter, we're on the ILS right now. So we're gonna go 2,700 here, and then 2,300 at PAMI is what we're looking for. So we're a little bit left of course right now, so we need to go to the right just a little bit here to re-intercept. Remember, as we get closer to the runway threshold, this is going to get a lot more sensitive, so you got to be really careful. Our glide slope is starting to kind of come in just a little bit here. We're going to look at that. We want to be looking at our airspeed as well. We're on with PWK here, and we want to look at that altitude. Kind of a nice 400, 450 foot descent. We don't want to be really diving and going up, really limiting that VSI, using that VSI as some trend. And you can see our glide slope is starting to come in here just a little bit. In terms of how far are we from PAMI, you can see right here, we're 4 nautical miles away from PAMI. So now what I want to do, something, I want to fail the avionics here real quick. So we're going to do that, and I'm just going to put it on heading and altitude mode here, just really quick for the autopilot to just hold me there for just a hot second, because what we're going to do, we're going to go and hit display backup, and that then puts me on reversionary mode there. Okay, so here we go. Get the airspeed up just a little bit, between about 85 and 90 knots, down to 2,300 is what we're looking for. Let's bring that glide slope in and localizer in, and we've lost our glide slope as well. So you can see that here. We have lost our glide slope. And so what does that mean? Holy cow, our glide slope right here that we did have is now gone. So let's pause it again. And what does that mean? That means we need to default to localizer minimums now, okay? Instead of the ILS, which had vertical guidance. So we need to default to localizer minimums, which are 10, 20. And so we'll go ahead and we'll fly this, and we're going to update our minimums here to 1020 through the procedure. Now our minimums have updated to 1020. Let's get back on localizer here. We're approaching our next final approach fix altitude, and there's PAMI right there. We just passed PAMI, and that was 2,300. So we were 2,340 at PAMI. That was really, really nice. That's that outer marker blinking. That's what that is. Now, if you look at our airspeed, we're definitely fast. 105, way, way too fast at the final approach fix. So let's slow up a little bit. Let's bring that power back. Let's use airspeed altitude to pitch correctly. And so once again, we got to really manage that descent rate. We don't want to just dive down super quickly. We want to manage that descent rate really, really, really nice and smooth here, about 450, 500 foot per minute, 85 knots or so. There we go. It's coming down real nice, just like that. Now, normally we would actually get configured at that half dot deflection, right? So when we had that glide slope there, that half dot deflection is when we would configure. I paused it real quick. That half dot deflection is when we configure. Otherwise, on a non-precision approach, you configure at the final approach fix. If you remember, PAMI was that final approach fix. So we're going to go ahead, we're going to configure. That's under 110, first notch of flaps, and then we're going to go ahead and make that approach about 85, 90 knots or so. And we're going to keep that approach coming in really nice. We're 5 miles away. Our minimums are 1020, so we are about 900 to go on minimums. 900 to go, we're approaching 800 to go on minimums. You want to be always calling out how far away you are from minimums. I'm really working hard to maintain that localizer, I would just say, trend. We don't want it to fall out of deflection. We got to keep it right there in the middle. You're working, if you're a student, you're working really hard at this point. You're managing this whole picture, right? Because I've lost my PFD, I've lost my glide slope. To be completely honest, I don't know how we lost the glide slope. Some setting somewhere in the sim, we lost the glide slope. So that was that. Once again, I'm not even looking outside. I haven't even looked outside once. I have kept my eyes locked right here on the localizer. And so if we're looking here, 2 mile final for runway 16. That's where we're at right now. And it says I'm 5 out of, here we go, 2.2 until that. So you can see I started looking at something else, lose my localizer just a little bit. Let's get that back. And we're gonna keep coming down right here. VDP is about 1 mile out So I need to be at my MDA of 1020 about 1 mile out. So we have 400 to go until the MDA. 400 to go to the MDA, and we got 1.5 nautical miles away. Once again, gotta watch that airspeed here. We got going a little bit fast. We're starting to think a lot about the altitude. So we're just gonna bring that power back a little bit. And that's 100 to go until minimums, 100 to go until MDA. And so we're gonna use that pitch for airspeed. And see when I pitch back a little bit and bring that power out, we're right back there. We don't wanna fall under the power curve though. You wanna still keep some power in, about 1700 RPM would be good. So look at that MDA. We don't wanna fall under that MDA of 1020. So we don't wanna fall under that MDA of 1020. Looks like 1 mile out was our VDP, and we can go visual. Okay, so once again, since we lost that glide slope indicator, we had to default down to an MDA versus a DA because we didn't have that vertical guidance. So we had to go a little bit higher for an MDA. So we're just right there at our MDA 1020. And that's something where then I talked about the VDP earlier. The VDP here on this chart appears to be about 1 mile out is where the VDP is. We're set up here, I paused it a little bit late, we're 0.6 out, so we're a little bit closer into the runway than I'd want to be from when I paused it. But for the sakes of the simulator here, you kind of understand the point. And so we're at our MDA, we're at our VDP. I need to see if I can go visual and make that descent to landing. So let's go ahead and see what that looks like. Okay, so I'm looking here, and there it is. Runway and identifier lights, I see them. I also see the runway lights. I also see the runway threshold. 91,175 says I can still make that stabilized descent because I was at that VDP and MDA. So I'm continuing. I'm leaving MDA, announcing leaving MDA. Full configuration for landing configuration here under 85 knots. And here we are. We're bringing the power back, keeping that sight picture in really, really nice. And we're going to make that landing just like that. 1,000 footers there, bleed off a little more airspeed, aileron into the wind just a little bit more, and there is the touchdown there. So there's our braking, little aerodynamic braking as well there with the yoke, and there's our brakes coming in. So there is the ILS. We had some very interesting things happen in the ILS. We lost our PFD, so we had to use revisionary mode and shoot the ILS here, looking at the right side. We lost our glide slope as well, so we had to default from ILS minimums to an ILS DA to localizer MDA minimums. So that happened. So these are things that, these things can happen, right? And that's why you practice these things in the training environment. So incredibly important to do that. So that's our approach. Thanks for tuning into the approach. I hope you learned a couple of things. Once again, these are just very much on the top level. I will say, the sim, it flies things a little bit more digital than in real life. So I think I might have to work out just a few of the response curves so it's not so touchy. But what great practice to use all this here. And so from there, I want to talk a little bit about the EFOS. I want to talk a little bit about SWITCHO-RADIOS, what those are like. And let's go ahead, let's get into that portion of the video. Okay, so we've got some pretty cool products here. This here is the EFOS and the SWITCHO-RADIOS. I'm gonna go ahead, gonna power them on. There's just a power button on each one here in the bottom right-hand corner. And so these are gonna power up. And once again, this EFOS, it's like a mini G1000. It's so wild, it's so unique, it's so different from anything I've ever seen. It actually transmits all of its data and information over an Ethernet cable. So it's taking all the telemetry data out of the simulator, it's processing it through Virtual-Fly Hub, then it's processing it through the onboard computer in the EFOS, and then it's displaying all that information. And then the touch commands that you can use with the actual touch screen of the EFOS then get sent to the simulator as well. So it's just a completely connected solution that actually doesn't require any HDMI connections, so it's not taxing on your graphics card at all. And it's just really simple, and it just really works. And we also just updated the latest firmware on the SWITCHO-RADIOS. Once again, these are still in development. They're just about done. Everything's launching November 2022. So here right about September, October, we're just about all done with all the programming and everything. Virtual-Fly is doing an incredible job. And they've requested a lot of our input too, which has been really, really cool. So I'll go ahead here. They're both on. We'll walk through EFOS here first. As you can see here on EFOS, it looks just like
a G1000, but the bottom here, which there's normally soft buttons, it's actually all a touchscreen. So if you wanted to bring up those leaning procedures for the engine, you push engine, lean, and there you can see, right? So if you want to hit that 1400 EGT and then enrich a little bit, you can do that all right through that system. You can push back. Got an annunciator warning here. Take those away. If you want to put transponder in, so here's transponder code. Let's say 3, 4, 5, 6, and there it shows up 3, 4, 5, 6. So all of these things, we want to change the nav source, VOR12, GPS, we're in route mode. So it's really quite neat how all of this actually works together. There is an entire autopilot built into this. You can select different aircraft types, right? You can select twins and things like that. So here's just Cessna 172. If I want to adjust altimeter and things, you can just do that right here with the altimeter knob. So there's just a lot of really neat things here that you can do. So you can see how that altimeter is moving, just like that. Okay, this is in a little bit of a demo mode, but you kind of get the point a little bit. In terms of comms and all that, we got comms up here, and you can adjust between them right here, and so you can adjust all the different types of comms and whatnot, and you can see it's just switching right there. Same with navs. So it truly is like a mini G1000. It's so unique. I can even put the wind right in here. So option 2, where it gives me both the wind direction and everything. I can have that all right there. So EFOS, it's like a little mini G1000, meets touchscreen, meets no soft buttons. So very, very, very unique and something that I've never seen before in the flight simulation space. So if we come over here to SWITCHO-RADIOS, SWITCHO-RADIOS is really unique. I like to say these really go together. You've got your other switch panels, engines, trims, and lights, and those are kind of a package. And then I say that these are really kind of a package too. They kind of go together. And so on SWITCHO-RADIOS, you can actually go through all these different things. And one of the firmware updates that we just brought forward, a recommendation we had, if you look at transponder, see there's a 4-digit code and then there's a mode. And one thing that I found, it was very confusing to understand where you were in the transponder. Am I in the numbers or am I in the mode selector, and kind of what mode is selected? And so now it's just a very clear numbers to mode progression. So if I get that code again, right? So if I go over here, my code was what, let's call it 2, 3, you just push it in and you spin, 4, 5, that's my code. Now I push it in again, and now another box highlights, and now I'm in mode selector. So I can be off, standby, on, or altitude reporting mode. So let's just put us in the standby, push it in, and now that box goes away. The box goes back to the code, and now I know I'm adjusting the code. Right? So it's all about having really great user interface and UI for what you're doing in the avionics here. So really, really cool. Once again, I mean, you got autopilot mode here. You can set your altitude to, 3,000, for example. The idea when all this is connected in the simulator, if you bug 3,000 here, you'd get 3,000 over here on the EFOS as well. So they really work together as a system. You can adjust your course. You can do your heading, autopilot on, off. You're going to have an entire annunciator panel. So if you're seeing anything from an annunciator panel perspective, you'll see that there. Once again, all your frequencies, nav 1, nav 2, you can just change them right here. So really, really cool functionality. You got flight level change and vertical speed change. The difference between those two, flight level change uses a fixed airspeed to climb, and then vertical speed uses like a foot per minute, right? So if you want to do a 500 foot per minute, what's going to happen to your airspeed? You got to kind of manage that a little bit. Or do you want to say, hey, I want to climb at 85 knots, and then your foot per minute's going to fluctuate, right? So a couple different things like that. Those are the differences between those two. Nav, VNav, vertical nav, just things like that. So a lot of different stuff here. This is EFOS and SWITCHO-RADIOS. A lot happening here, something very, very new. And this is mounted to our modular plate for the flight deck. So you can pick any type of avionics. As you saw, the Aviatek G1000 or the EFOS and SWITCHO-RADIOS. You can pick a real sim gear G1000, a simionic G1000, the virtual fly G1000. If you want to run a steam gauge setup where you want the air manager with the knobster and a touchscreen, or let's say you get the Aviatek option which already has a touchscreen built into it as well, and you can use the knobs just like a knobster. So there's so many different possibilities with our new flight deck and SLAVX modular flight deck system that you can really just build in as much flexibility as you want for the future. So that is EFOS and radios. Okay, so that's about a wrap for today's video. Thank you for taking part and watching the entire 3-part series where it started with Oscar and myself talking about SWITCHO, building the flight deck, and then the entire integration of the SLAVX cockpit, finishing it off. Really bringing everything true to life just in the place that it was designed to be. So this is really the biggest, ultimate cockpit setup that we've ever done. When I set out to start this company 4.5 years ago, I really wanted to change my aviation journey, but I wanted to change the aviation journey for other people as well, either whether or not you're training, maintaining proficiency, or you're just an enthusiast. And we've had the opportunity to change that with hundreds and hundreds and hundreds of people, and that has been so incredibly moving for us and everybody at the company. It really gives us the energy to do what we do. Can't take the enthusiasm out of a passionate aviator, so to speak. But once again, you've seen a lot of the different things. You saw the Aviatek G1000, you saw the SLAVX cockpit, the computer setup, the EFOS, the radios. We covered a ton in this video. Thanks for coming on the ILS 16 turned localizer 16 in the Chicago executive with us also. I thought that was a fun approach to do, and a lot of different things that are great to practice in the simulator environment. So, we're always continuing to innovate here. We're always continuing to partner. We're always going to continue to keep bringing you more content when it's relevant and when it is time to really announce to the community, both aviation and flight simulation, whether or not we got something new that's fun and something that you may benefit from as well. So as always, we'll catch you later. Stay level.